Welcome to solverfy.
Okay, so the question was asking us to find the index of refraction of air at atmospheric pressure. So we have such equation with delta phi equal to 2 pi over lambda times delta lambda equal to 2 pi over lambda times 2d times n minus 1. Okay, so this is the equation for the relationship between the path difference and the phase difference of light rays. Delta phi is the phase difference of light rays, lambda is the wavelength of the light rays, and delta lambda is the path difference between the refracted ray and transmitted ray. The reason why delta lambda is equal to 2d times n minus 1 is because the path length for the refracted ray is 2dn, and the path difference for the the path length for the transmitted rays is 2d. So the difference between the refracted ray and the transmitted ray is just simply the path length of the refracted ray minus the path length of the transmitted ray, which is 2dn minus 2d. And if we do some arrangement, we'll get is 2d times n minus 1. Okay? And so we know the fringe pattern of light rays can shift by one fringe for each phase change of light rays. Therefore, we can have another expression, which is this expression could be for the phase change of light rays, which is delta phi is equal to I remember it was 2 pi, and delta phi here is the same thing. It's the path difference. The phase difference of light rays. Okay, delta phi is the phase difference of light rays, and n here is the number of bright fringes. So we can set out these two equations to each other, to equal to each other. So we get 2 pi over lambda times 2d times n minus 1 equal to 2 pi n. Okay, and remember d in this case just the length of the chamber. Okay, so if we do some arrangement, because our goal is to find the index of refraction n, so we need to set that n on the left side. Okay, let's do some quick arrangement here. So we get 2d n minus 1 is equal to 2 pi n times lambda over 2 pi. Okay, so 2 pi and 2 pi cancel out. So we get 2d times n minus 1 is equal to n lambda. N minus 1 is equal to n lambda over 2d. So n, the index of refraction, is equal to n lambda over 2d plus 1. Okay, so now we can plug in the value to determine the value of index of refraction, which is n is given as 60. Okay, so there are 60 bright fringes. So 60 times the wavelength, which is 500 nanometers. And if we convert 500 nanometers to meter, we'll get 500 times 10 to the power of -9 meter over 2d, which is 2 times the length of the chamber is given as 5 centimeters. So 2 times 5 times 10 to the power of -2 meter, because 1 centimeter is 10 to the power of -2 meter, and then plus 1. And we'll get the index of refraction number is 1.00030. Okay, and this is the answer for the question. Thank you.